Once we can identify matter, now we want to look at some of the properties. We know from everyday life that different substances have different behaviors. So those are the properties that we're talking about. For example, we can compare the compound water to the compound ethanol. One of the behaviors or one of the properties we can look at in chemistry is what temperature will make the substance freeze. So water freezes at 0 degrees Celsius. Ethanol freezes at negative 117 degrees Celsius. Besides that type of property, we can also look at reactions. Ethanol can be burned, which means it is combustible. That's a different type of property. Water, obviously, is not combustible. So, in addition to comparing two substances to see how they react at different temperatures, a lot of chemistry is focused on how things react together. So this example of combustibility is another way of saying, does this chemical react with oxygen? And ethanol does, and water does not. This type of reaction leads us to our next property, our next topic rather, which is looking at changes and identifying whether they are physical or chemical changes. A physical change is a change in which you end up with the same substance that you started with. So at the beginning of the reaction and the end of the reaction, you still have the same substance. If you put a tray of water into the freezer and you make ice cubes, it was water when you started, and we're going to identify that we had a liquid with parentheses and then an L, and then it turned into water in the solid state. It's still water before the reaction, and it's still water after the reaction. So that would be an example of a physical change. A chemical change is a change in which you make a new substance. At least one new substance is formed. So you can make one new substance or more than one. That's why I have the parentheses S. This does not mean solid in this case. Here's a picture of an iron nail that has started to rust. So at the beginning of the reaction, it was all solid iron. Rusting is a reaction in the air, just like a combustion reaction, very similar reactions. And this rust is a combination of iron and oxygen. So that's why they're trying to show the new atom connected in red is showing that it is a chemical change. One way to keep track is to look to see if the only change is the appearance, then that will be a physical change. It's easy to tell when you look at an example that shows the microscopic pictures. Here's an example of a cigarette lighter. It is made with liquid butane, so you have butane under pressure that keeps it in the liquid state, and on the left hand side what they're showing is someone has opened the container and the liquid evaporates under low pressure and it turns from liquid butane into gas phase butane. It's still butane. The only thing that changed was the appearance. That's a physical change. On the right, if you create a spark, you can get a chemical reaction between the oxygen in the air and the butane as it goes from the liquid to the gas. And so they're showing the new substances that are formed, which is carbon dioxide and water. When you burn something like butane, you always make carbon dioxide and water as long as you have enough oxygen around. So because we made new substances, this is a chemical change. Another example, what if we dissolve sugar in water? Sugar, remember, is C6H12O6, and it starts off in the solid state. If we dissolve it, we'll make a solution of the same substance. Dissolve in water means it's an aqueous solution, so we write that as AQ. It's the same substance before and after. It's a change in appearance, so it's a physical change. And we can prove that because once you have the sugar dissolved, if you evaporate all the water away, you'll be left with the same solid sugar that you started with.